You know, both Pepperidge Farm and I remember a simpler time and a simpler network. And I'll stop talking like that now, I promise. But here's that simpler network I was just referring to. And this is another reason I wanted to kind of cut this lesson into two videos, because I needed to set up a separate lab to show you the next top attribute default, or that calculation that we saw the iOS mention. Router 3 is advertising its two loopback interfaces over to Router 1. Router 3 is an AS300, Router 1 is an AS100, and all three routers you'll see in this lab are on the 172.12.123.0/24 network. So nothing fancy going on here. You see the next hop is 172.12.123.3. That's intuitive, makes perfect sense. But let's verify anyway by going over to Router 1 and running show IP BGP. There are the two routes, and the next hop's 123.3, and everything is exactly as we would expect it. Now, when a BGP speaker advertises a route to an eBGP neighbor, and that's just what we saw, 3 and 1 are eBGP neighbors, the next hop address is going to be that of the advertising interface, which again is intuitive, and we saw that in the table. Now, it makes perfect sense, but here's the slightly odd rule. With iBGP route updates, if the route was originated outside the local AS, the next hop address is still the source address of the router in the remote AS. Weird? Yes. but it's true, and that's why I was really hitting you over the head earlier with, watch that I, watch that E, because the internal versus external really has a huge impact, as we've seen, on how routes are advertised, and are certain routes even considered for BGP? Well, we saw a couple of inaccessibles in the last couple of videos, and we know why. Now, we're going to prove that theory by going down and checking router 2, because I still kept the adjacency between routers 1 and 2 in AS100, and right now router 1 is sending an iBGP update. So the next hop should be 123.3. Let's try and bring that equipment up and keeping it there this time. There we go. And show IP BGP on router 2. And there it is, 123.3. So again, and this comes up a lot. If an external router, the two routers involved are external, then the next hop address is always going to be that of the advertising interface. But when you have this situation, when a router has learned a route from an external neighbor and is then advertising it to an internal neighbor, the next hop remains intact. It doesn't change. So here, in this particular lab, no big deal, because router 2 can reach 172.12.123.3, and there's no problem at all. But as we saw in the previous couple of videos, if that router 2 can't reach those other routes or that next hop address, then you're going to have some problems creep in. So that's what the heck was going on. A lot going on there with the next hop address, but that stuff can drive you crazy if you don't keep that one simple rule in mind. Coming up next, we're going to go back to that MED, and what the heck is a multi-exit discriminator. You're going to see what it is, and you're going to see it in action coming up next.